Okay, I'm going to post a video for the review that we worked on in class today for anybody that wasn't there, or if you need to do a retake or something like that, it'll be available for you to watch. So this one is helping to see 1, 2, and 3 all have the exact same problem and the exact same answer. They even give it to you. They're telling you when you graph these, they should cross at 0, 3. So what you're trying to demonstrate is that you know how to graph them properly. And on this one, we're trying to see if you know how to put it in slope-intercept form. So I'll start with the top one. It has a y-intercept of 3 and a slope of 2. It's kind of hard to see the lines on this. And this is not inequality, so I can just connect them with a straight line. I'm not shading anywhere. This one, I'm going to subtract the 3x on both sides. And then I've got to divide everything by that 5. So y will equal negative 3/5 x plus 3. I can come over here and graph that. So it starts in the exact same spot and a slope of 3/5. That's hard to see. Looks like it's there. 5 and there. I know what I messed up on. I'm looking over here. I lost my negative, so let me bring that down and erase these dots. My slope is negative 3/5, so I'm going to go down 3 and over 5, up 3, over 5. Well, hopefully if you made a mistake, you caught it like I did. So when I am correcting your test, I am looking to see this will be worth a point. Each one of these will be worth a point with the y-intercept in the correct spot and your graph in the correct spot. Or your slope, excuse me. Okay, same equations, but this says to use substitution. And I should get that exact thing. So it's already, step number 1 is done. This is solved for y. So I can go ahead to step number 2, where I'm going to substitute 2x plus 3 into the other equation for y. Now I can solve. So again, as I'm grading this, because you're supposed to be demonstrating substitution, that will be worth a point. So I'm going to go ahead and solve this. 13x, I'm combining these like terms. I'm going to get that 15 on the other side. 15 minus 15 is 0. And 0 divided by 13 is 0, which is not a surprise. That was the goal. Once you get that, the next step I'll be looking for specifically is that you've taken it back and substituted it in to find your y value. So y equals 0 plus 3. Y equals 3. Not surprised. That's the other value I was looking for. And the last way is substitution, or excuse me, elimination. So I need to get opposite coefficients, but I'm noticing that my columns are not lining up properly. I should not have x's and y's all lined up together. So I'm going to fix that by, I think I'm going to subtract 2x from both sides here. So I'll have negative 2x plus y equals 3. Now everything is lining up a little bit better, and I'm going to multiply the second equation by a negative 5. You could multiply the top one by a negative or a 2 and the bottom one by a 3 and create opposite x's. I'm not going to do that. So I'm going to rewrite this one a little bit lower so that they kind of line up nicely. Because again, I'm earning points right now showing how good I can use elimination. So these are eliminated. It's very easy for me to see that. What did I mess up on? All right, I found my mistake. I'm just trying to go too fast. So when I distribute my negative 5, I need to distribute it to the negative 2x to the y, which I did, but I got going way too fast. And instead of multiplying it by that 3, I just brought down the 3. So this is what I'm expecting it to look like. I want my x to be 0. Okay, so yes, that matched up. I caught two mistakes because I need to slow down a little bit. Y equals 2 instead of x, I'm going to put a 0. And this looks just like up above. So I've now shown that I know how to eliminate. This is worth a point. Just showing that is worth a point. Same thing with substitution. Just showing that step is going to be worth a point. Which one do you prefer and why? As long as you pick one, your three options are graphing, substitution, and elimination. And then explain to me why you like it the best. Those are easy points. Okay, number 5, it asks for the slope and the y-intercept. And then it says determine if they have one solution, no solutions, or infinite. So the slope here is 2. The y-intercept is 4. The slope here is a half. The y-intercept is -2. So maybe you don't even know like what it's asking about. So you're welcome to graph your graphing calculator and graph these. So here's the top one. It'll look something like this. The next one starts down 2 and then rise 1, run 2. Looks like they're going to cross somewhere over here. My graph's kind of small. So this will have one solution. It almost looked like it was going to have no solutions, but they're definitely not parallel. They're not parallel. So even though I can't see on my little picture where they're crossing, I can tell they're going to cross once. Okay, I'm going to look at this next one. The slope is 1/3. The y-intercept is 2. This is not in slope-intercept form. So it's kind of hard for me to say what the slope and the y-intercept are until I put it in slope-intercept form. So the slope is 1/3. The y-intercept is 2. Rise 1, run 3. Let's go to the second line. Same y-intercept, same exact slope. This is infinite solutions. All right, so if you're not sure on these, after you go through all that, grab your graphing calculator, graph them. You do have to put them in slope-intercept form, so you're going to have to do a little bit of work, but that's how you'll earn your credit on there. Okay, this one says I can choose any method I want, and then it talks about this weird graphing calculator window. If you want to solve these by graphing, please just draw me a graph in the space provided. So I wasn't going to solve any of them by graphing, but if you want to, that is fine. Put them in slope-intercept form and draw me a little graph here and show me what they would look like. Okay, as I'm looking at this one, I think it would be pretty easy to solve by elimination. So I'm going to make my coefficients opposite. I'm going to write my answer kind of down here. Okay, so I'm done with that equation, and these two are ready to eliminate. If you used a different method, you just won't be able to follow along for a minute. Our answers are not going to look the same. Divide both sides by -49, I found that y equals 0. Now I can come up and plug it into any equation that I want. I think this one actually looks easiest. So 14 times 0 is 0, so x equals -3. And if you're not sure, plug the -3 and the 0, plug them into your equations, and it should be true. This should equal -3, this should equal -12. You can check your answers on these. Okay, there was a typo. We decided this should have been an x, or a -x, excuse me. And I think that elimination would work the best again. So I'm going to multiply this one by 2 so that my coefficients will be opposite. Well, that's a big number. I'm going to bring this one down below it so that they'll kind of line up. My x's will eliminate. And when I divide, y will equal 6. I'm going to substitute that back in. I think it would be easy in this one, maybe. 2x minus 2 times y equals 12. I'm ever going too fast, that's the good thing about a video. You just stop or pause me. When I divide it out, I find that x equals 0. So I've got 0, 6. These could always be 0 solutions or infinite solution, by the way. What's the easiest way? Well, these are not lining up very well. Substitution might be the best because it's already solved for y. So negative x plus 4, instead of the y, I'll put negative 6x plus 13 equals negative 23. So I've got to distribute here. These are going to be some big numbers. Let's see, 13, 2. Let's combine the like terms. We're going to subtract 52 on both sides. When I divide by a negative 25, I get x equals 3. I still need to find the y. So y will equal negative 6 instead of the x. Let's plug in that value that we know. And negative 12 plus 13 is 1. All right, I'm wondering if I should graph any of these just so you can see what they would be like. Do I want to do that on these ones? No, I'm not doing it. I don't want to have a negative 9/4 for a y-intercept. I think that this might be easy to multiply this by a positive 3. So let's make sure I distribute all the way through, which I almost did not do last time. Let's add them together. Oh, that's actually different than what I did on my key. My answer key, I used substitution. So when I divide it out, y will be negative 2. I can plug it back into either one of these. So we've got x minus 8 equals negative 9. Okay. You have 3 times as many TikTok followers as Instagram followers. Sounds like I have more TikTok followers. So if I take my Instagram followers and I times them by 3, it will give me my TikTok followers. That might feel backwards of how you read it, but it's just true once you think about it. And then it comes along to say I have a total of 600, so TikTok plus Instagram is 600. This seemed to be the troublesome equation. 3 times as many TikTok followers as Instagram. From here, I can use substitution. That seems to be the easiest. So instead of a t, I'll put 3i plus I equals 600. And divide both sides by 4. My Instagram followers are 150. And then I can plug that into either one of these. TikTok plus Instagram, which I now know is 150, equals 600. Use my inverse operations to find that my TikTok followers is 450. So your 2 solutions are here. I don't know how you'd write them as an ordered pair. I don't know that that's important. Why isn't it going? Oh, there we go. Okay, these are inequalities, so please shift gears with your brain. Think dashed lines, solid lines, shading above, shading below, lots of things to think about. Box and Hoy, this is a horizontal line on 3. It is dashed because it just says y is less than. This one has a y-intercept of -1 and a slope of rise 1, run 1, rise 1, run 1. And it is solid. And it says y is greater than. Okay, so this is the piece that I'm looking at here. All right, so which ones are the possible solutions? I should probably pick a crazy color. So over 0 up 2. Yep, that is in the colored in part. -3, +3 is here. That's on the dashed line, so it will not be a solution. Yes, that is correct. These are hard to look at. Okay, 3, 5 is going to be up above. -3, -2, oh, that's definitely in the good area. 2, 1, looks like it's right on the line, but this line is solid, so it's a good one. And 2, -2, definitely not. That is hard to look at, just saying. Okay, graph the system of linear equalities, vertical on x, and it is dashed again. X is less than the 3. Let's hit our +4 for my y-intercept, and rise -2, run 1, rise -2, run 1. Looks like it's solid. Ooh. I want to try to make it straight so I can see if these are solutions. Y is greater than. I'm going to shade up here. So the part that's double shaded is here. And it obviously keeps going forever, but that's what I'm looking at. 2 possible solutions. You just have to pick some. Like if I go over 1 and up 3, like right here. If I go over 2 and up 5, I'm like here. We are not going to have the same answers. 2 non-solutions. 0, 0 is an easy one to see. -3, 1 is easy to see. Okay, there's 2 ways to solve this. You can solve by elimination, or you could substitute, and I might just show you all of them. So -y equals 5x minus 9. Now I can add these 2 together. My y's will cancel out. My x squareds do not have like terms. Hey, my x is canceled out. So I'm going to solve this algebraically. You could use this if you want to. Take the square root of both sides. So x equals positive or -4. These are supposed to be ordered pairs. So once I've got these x's, I need to plug it back in. I would suggest plugging it into the linear equation. Instead of the x, I'll put the -4 and the +4. Okay, -20 plus 9 is -11. And 20 plus 9 is 29. So -4, 29. All right, that's it. At least I think so. Is there a back? Nope.